All right, sixth graders, here we are, Chapter 1, Lesson 4, starting on page 39. I just got done eating, so don't have anything in my teeth. Doesn't matter. You guys can't get that close to me anyways right now. So, it's perfect. We're going to start taking a look at ratio tables. Remember, we talked about rates, we talked about ratios, we talked about unit price. So now we're going to kind of bring it all together, and we are going to start studying ratio tables. So we're actually going to skip this first page and jump right on into the bulk of the lesson, because that's where we can get a whole bunch of information. So go ahead and get your book open to page 40. Remember, I'm always kind of going between my device here and my book because I always make a ton of notes in my book, which is why I have a tendency to mess up on my videos because it's right in front of me and I'm not paying attention to that. Probably like you're not paying attention to me. It's okay. All right. I get it. At any point, if you need to get up and stretch, do that. That's always a good thing. And here we go. So we're going to get started right away into equivalent ratios on this page. So it says the quantities in the opening activity were organized in a table, which we didn't do that activity, but it's not a big deal. I'm going to teach you about a table. Okay? You have seen a table, you know what it is. Not the table that you eat at, rather the math table. Okay, this table is called a ratio table. Again, that's really important. So if you have a piece of paper next to you, a spiral where you can keep these definitions down, that is always good because, again, you'll get to use it on quizzes. And sometimes I even allow you to use it on tests. Or if you like to write it on a note card, write it on a note card. You do what is best for you. Okay, so these are called a ratio table because the columns are filled with pairs of numbers that have the same ratio. So if we were comparing soda to juice, so let's say if we have 1 can of soda right here, there's going to be 3 juices. So like we're making a punch. Okay, so for every 1 can of soda, we're going to have 3 juices. So if we have 2 cans of soda, that means we're going to have 6 cans of juices or bottles of juice. See what's happening? If we have 3, then we're going to have 9 because we know that our unit rate is for every 1 can of soda, there's 3 juices. So if I have 2 cans of soda, I have to have 6. All right, so forth and so on. All right, take a look at this. It says, to make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. How much food coloring should there be if you mix 5 cups of white icing to get the same shade? So take a look at the table that they drew. This is what we're working on, the table. They have drops of yellow and then cups of icing. So they told us that it was 6 drops of food coloring for every 1 cup. So that's where they got the 6 that's right here and the 1 that's right here. That's where we're starting off. And they say, what's going to happen if you have 5 cups of icing? So notice that they have put that there, which means this would have been empty because we didn't know that answer right away. So we have to figure out how I get from 1 to 5 by multiplying or dividing. Those are the 2 operations we're going to use. To get to 1 to 5, we multiply by 5. Whatever I do to the bottom of the table, I must do to the top of the table, and vice versa. Whatever I do to the top, I have to do to the bottom. You're going to hear me say that over and over and over again, not just in this lesson, in this chapter, but you're going to hear me say it when we get to fractions. So if we multiplied by 5 on the bottom, that must mean that we have to multiply by 5 on the top. So we're going to multiply this top number by 5, which is going to give us an answer of 30. Okay, so therefore we would use 30 drops of icing or 30 drops of yellow if we have 5 cups of icing. All right, Joey Chestnut. I love Joey Chestnut, and you're going to see in this lesson that I've attached something really fun that I absolutely positively love to do, and it's phenomenal. Okay, so it says, in recent years, Joey Chestnut won the hot dog eating contest nearly 66 hot dogs in 12 minutes. Just process that for a minute. 66 hot dogs in 12 minutes. 12 minutes, guys. I don't even eat 66 hot dogs in a year. Okay, my dad, on the other hand, goes to like baseball games and he can scarf down like 3 and then he's full. This dude ate 66 hot dogs in 12 minutes. 12 minutes. That's crazy. Okay, so I want to know how many can he eat every 2 minutes. So watch what happens. We have 66 hot dogs in 12 minutes. Okay, so 66 hot dogs in 12 minutes. They've actually broke this down into 2 different sections, which I think is phenomenal because we both know that 66 and 12 have a common denominator of 2, right? So if we divide each of these first by 2, that's going to give us 33 over 6, which means in 6 minutes, this dude eats 33 hot dogs. Okay? Now the question is asking how much does he eat every 2 minutes? So I want to get to 2 minutes. So if I divide it here, how can I get from 6 to 12? Whatever I do to the top, I have to do to the bottom. Whatever I do to the bottom, I have to do to the top. I can divide that by 3. I know that I can divide evenly 33 divided by 3, and I get 11. So that means in 2 minutes, this guy eats 11 hot dogs. Now, if we were to break that down to a unit rate, if there's in 2 minutes, he does 11. So think about it. In 1 minute, he eats 5.5 hot dogs. Oh man, that's crazy. That's crazy. But anyways, we will get to the cool activity later or either when I see you next time. Okay, like in person when I see you. Okay, let's take a look at a couple of these problems. It says a patient receives 1 liter of IV fluids for every 8 hours. Notice how they have this table set up. 1 liter right here, and then they have the time, 8 hours. At that rate, find out how many liters it will be for 4 hours, for IV fluids. So notice they placed the 4 up here, up at top, and I need to figure out how I get from 1 to 4 by multiplying or dividing. Well, since my number is getting bigger, and I'm not talking fractions, I'm going to multiply by 4. So whatever I do to the bottom, I have to do to the top, or whatever I do to the top, I have to do to the bottom. So if I multiply this by 4, I must multiply this number by 4. So 8 times 4 is 32. So my answer would be 32 hours. Okay. The next one, it says to make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. So 12 cups of sugar, 16 cups of cranberries. I want to know how many they need for 4. And when I do a table, guys, I do always like to leave an extra space right here just in case if I have to go a couple of times to get to my answer. So when I look at this, 16 and 4, or 16 and 12, I know that I can divide each of those by 2. So let's start off with dividing each of those by 2. Okay? And just get to this next number. So whatever I do to the top, I have to do to the bottom. So 16 divided by 2 is 8. 12 divided by 2 is 6. So for every 6 cups of sugar, I now have 8 cups of cranberries. How do I get from 8 to 4? 8 divided by 2 is going to give me 4, so therefore whatever I do to the top, I have to do to the bottom. If I divide 8 divided by 4, can I do 6 divided by 4 and get an even number? No. So we want to make sure that we're sticking with numbers that are going to give us even numbers. Not even numbers, but whole numbers. Okay, 6 divided by 2 is 3. So my answer here is 3 cups. Okay, let's go over to the next page. Scaling. Okay, so scaling is something really cool. Scaling is where you are going to have to multiply and or divide in the same table. Okay, so the other ones that I showed you, we like divided twice, or we just multiplied. Here we're going to have to do a little mixture of both because we might not have a greatest common factor right off the bat that's going to get us to where we need to go. So we're going to have to do some scaling, which means sometimes we're going to have to scale back and then scale forward to find that equivalent ratio. All right, let's take a look down here and I'll show you what I mean. Okay, it says a child's height, so this is on page 41, okay, down at the bottom, right here. It says a child's height measures 105 centimeters. Estimate her height in inches. Okay, so I have 105, and I know that 25 centimeters is about 10 inches, okay, in height. So I have to end up working backwards, okay, or I'm sorry, scaling forward to scale back. So I need to figure out, if I'm starting at 25, how am I going to get to here? What can I do with that number to get to here that's going to help me when I get from here to here? Okay, so I know when I look at these two numbers, I know I could start off dividing by 5 just to see what happens. Okay, so if I divide 25 divided by 5, I get 5. 10 divided by 5, I get 2. Now, how do I get from 5 to 105? Well, I know I'm getting bigger. I know 5 times 2 is 10. So if I take 5 times 20, that gives me 100. So if I add on 5 more, I would really be multiplying 5 times 21. So 21 times 5, we're just going to check our math. 105, see how that works? So if I multiply that number by 21, I have to multiply this next number by 21. So 2 times 21, which is 42, so it is going to be about 42 inches. All right, let's go to the next page, and we're going to take a look at, oh, nope, see, it's messed up here. There we go. We're going to take a look at number 1 and 2. It says, Santiago receives $7 every week. How much total does he receive after 4 weeks? So he gets $7 for every 1 week. Okay, but I want to know what he's going to get after every 4 weeks. So let's say if we have 2 weeks, how do I get from 1 to 2? Well, we're going to multiply. Remember, it's only multiplying or dividing. We're going to multiply by 2. If I multiply the bottom by 2, I have to multiply the top by 2. So 7 times 2 is 14. Makes sense, right? Because we're doubling. So here I go. If I am at 3 weeks, okay, think about if I am at 3 weeks, now I'm taking my original 1 week and I'm timesing it by 3. So I'm going to take my original 1 week and times it by 3, which gives me 21. Do you see the pattern? 7, 14, 21, 28. We are listing the multiples here on this one. Isn't that crazy? So after 4 weeks, he makes a total of $28. Okay, and you have to, guys, you have to do these tables. This is why we're doing this, okay, is to create the tables. We're going to do this next one, and then we're going to do, I'm going to set you up for some more examples, but we're going to do this last one right here together. All right, Tanya runs 8 kilometers in 60 minutes. At this rate, how long would it take her to run 2 kilometers? So the distance run is 8. The time is 60 minutes. We want to know how much she can run at 2 kilometers. All right, knowing what I know about these two numbers, I would think that I could probably divide both of those by 2. Okay, so I'm going to divide 8 divided by 2, which is going to give me 4. I'm going to do 60 divided by 2, which is going to give me 30. Now, can I get from 4 to 2? Yes. How do I do that? I can divide it by 2. Since I can divide this by 2, I have to make sure that I can divide my bottom by 2. Yep, 30 divided by 2 is easy, which gives me 15. So in 15 minutes, she is going 2 kilometers. Now, we're going to go ahead and do, on the next video, numbers 1, 2, 3, and 4. If you feel like you already have this, which some of you already do, cool. If not, watch that second video. It's going to be so helpful. Okay? So go ahead and you decide what you need.